Welcome to this explainer. Today, we're literally pulling back the pavement to examine the critical and rapidly aging gas delivery infrastructure right beneath our feet. We're going to take a really hard look at the complex and honestly, sometimes dangerous systems that power our cities.
It's a huge question, right? Especially for those of us living in densely populated urban areas, because the massive network of pipes providing our daily energy is growing older every single day. We completely rely on this system to cook our food and heat our homes, but let's be real, we rarely stop to think about the physical state of the pipelines buried right under our sidewalks.
So, here is our game plan for today. We're going to cover the hidden infrastructure threat, explosions and safety, the fugitive methane problem, how companies actually profit from pipeline upgrades, and finally, securing the grid.
All right, part one, the hidden infrastructure threat.
Let's kick things off with the physical reality of the problem resting directly beneath our neighborhoods. Gas distribution involves operating local, low-pressure pipes to transfer natural gas from larger transmission lines directly to end users like you and me. But here's the catch. Many of these urban networks suffer from rapidly aging infrastructure and, frankly, inadequate monitoring. Over decades of service, the materials originally used to build these grids just naturally begin to degrade, setting the stage for unintended leaks and system failures.
To really grasp the physical age and vulnerability of the grid, sustainability standards classify a very specific threat. They look at the exact percentage of a utility's distribution pipeline that relies on outdated materials. Specifically, they're hunting down two major culprits. First, cast or wrought iron, which can become incredibly brittle over time. And second, unprotected steel, which completely lacks modern corrosion protection. If a utility has a high percentage of these materials in their network, the risk of a leak absolutely skyrockets.
Moving on to part two, explosions and human safety.
When these older pipelines fail, the immediate stakes for human life and property are terrifyingly high. A loss of containment in a densely populated area isn't just an operational hiccup, it is a full-blown emergency. Because natural gas is so highly combustible, a leak can quickly result in catastrophic fires and fatal accidents. For the utilities operating these lines, these disasters completely destroy public trust and can result in massive, costly negligence claims.
So how do we track if a utility company is playing it safe? Industry standards require them to report three critical pipeline integrity metrics. Number one, reportable incidents. Number two, corrective actions. This happens when a facility is found to be hazardous and regulators step in to mandate immediate repair or restrict its use. And number three, safety violations, which are formal warnings issued for breaching pipeline safety laws. Tracking these three areas gives regulators and investors a super clear picture of how safely a grid is actually being managed. You might be wondering, what exactly triggers that first metric, a reportable incident? Well, the threshold is severe. An incident gets reported if it involves a death or an injury requiring inpatient hospitalization. It's also triggered if there's an estimated property damage of $50,000 or more. Or, and this is staggering to think about, if there is an unintentional gas loss of 3 million cubic feet or more. Just one of these incidents leaves a visceral impact on a local community, often causing major disruptions to everyday life.
Okay, part three, the fugitive methane problem.
Beyond the immediate terrifying threat of explosions, pipeline failures create a chronic, invisible problem for our environment. Since natural gas is primarily made up of methane, which is a highly potent climate-warming greenhouse gas, these continuous unintended leaks from aging pipes have serious ecological consequences. In the industry, they call these fugitive emissions. And as policymakers push harder to mitigate climate change, these fugitive emissions from aging iron and unprotected steel are drawing some really intense regulatory heat.
Now we have to make a quick but vital distinction here between these unintended leaks and what the industry calls process emissions. Process emissions are actually intentional. They are planned releases by the utility during standard, everyday operations, like venting to relieve pressure safely. Fugitive emissions, on the other hand, are those unpredictable, dangerous leaks that result purely from the infrastructure breaking down.
Which brings us to part four, profiting from pipeline upgrades.
Here's where things get really fascinating. It's a pretty unexpected economic twist. You'd probably assume that digging up thousands of miles of city streets to replace old pipes would be a devastating financial loss for utility, right? Actually, in regulated markets, utilities can earn a return on the capital investments they make to replace dangerous pipes. Why? Because these massive upgrade costs can be factored into their regulated rate base. That means the allowable rates they charge to customers are adjusted to ensure the utility recovers its investment while making a steady profit.
It creates this uniquely aligned incentive structure.
By proactively managing these risks, utility companies protect the local community from explosions and shield the environment from fugitive methane, while also drastically reducing the risk of massive civil fines. And they do all of this while generating positive financial returns through that rate base we just talked about. Upgrading the grid isn't just good citizenship anymore, it's a highly profitable business move.
Finally, Part 5, Securing the Gas Grid.
So, how do gas utilities actually pull this off? How do they execute these profitable, highly necessary safety measures? Well, securing the grid isn't a simple one-and-done job. The solution involves a comprehensive, multi-step approach. It starts with aggressively replacing those outdated iron and unprotected steel pipes with modern materials. Then it requires regular, high-tech inspections. On top of that, pipeline operators must be thoroughly trained and rigorously qualified before touching any covered task. And lastly, there has to be a deep, company-wide culture of emergency preparedness.
Regulators aren't just taking their word for it either. To prove they are managing the grid's integrity, regulators closely monitor exactly what percentage of pipelines are being actively inspected. And they use some pretty wild tech to do it. They use advanced methods like internal smart tools, sometimes called smart pigs, that literally travel inside the pipes to detect corrosion. They run intense pressure tests. They use direct assessments to check for stress cracking. This constant push for advanced leak detection technology is what guarantees the integrity of both the massive transmission lines and our local distribution networks.
The stakes for these high-tech inspections are absolutely massive, especially for those large transmission pipelines. For instance, incredibly strict regulatory oversight kicks in for transmission lines operating at a hoop stress of 20% or more of their specified minimum yield strength. In plain English, when these pipes are operating under that much immense, constant pressure, there is zero margin for error. Rigorous, documented inspections are literally the only thing standing between normal operations and a catastrophic disaster.
As we wrap up this explainer, we're left with a really vital question. We know the pipes are aging, we know the physical and environmental risks are catastrophic, and we now know that utilities can actually profit from doing the right thing. But is the promise of a return on investment enough to drive utilities to proactively replace this critical infrastructure fast enough? Will the pace of their investments finally outrun the relentless aging of the cast iron beneath our streets before the next unintended leak occurs? That tension between aging infrastructure and corporate investment is the defining challenge for the future of our gas grid. Thanks for learning with me today, and keep asking the big questions about the invisible systems hiding right in plain sight.